back to another video. Unfortunately, I'm going to let my headphones charge overnight, so I'm not sure what the deal with that is. So it's going to be another non-headphone video. The last one I had where I was in my living room here, and I wasn't using headphones, so it was really weird noises happening. So I hope that doesn't happen with this, but unfortunately, this is kind of all I've got to work with right now. But anyway, so last video I was working through the IBGP and EBGP topic on the exam. I decided to skip over the last exercise because it is simply just for how to configure it in a logical system. And I don't think logical systems are going to be on the exam. They really haven't been working for me. So if they're on the exam, it's just the same thing as anything else I would imagine. I hope they're not on the exam, they might be. But I think I'm just going to skip that because I didn't have luck with logical systems before. And I can't get, let's see here. So the problem I was having before with why logical systems weren't working for me is because this is all meant to be on one device. Actually, you know what? I think I am going to try this. It's all meant to be just on one device, router 1. Although this says, yeah. So I think I'm going to try this just because I didn't know it was meant to be all on one device. So I did go ahead and set up the topology for the next exam, but I'm gonna, I think, close this out. So this will be the last video in the playlist for IBGP and EBGP, and then the next one will be for IPv4 and IPv6 peering communities. So kind of I'm taking a bit of a different path than I had thought I would take for this video, but I am very interested in having these logical systems work because this could be a way I can learn networking just using one device with 4 pixels, because each logical system is essentially its own router. So if you can use one router where you would have had to use 5 routers, you're going to be at a huge disadvantage or a huge advantage for learning networking. You'll be able to learn it in a much wider variety of situations. So I definitely want to learn how to use logical systems to learn networking. All right, so I think I'm going to actually rename this R1. Yeah. All right, and then I will configure all of this, and hopefully this will work. It's logical systems A. Perfect. And it's interfaces LT. Unit 1. Isolation Ethernet. Here, unit 2. And address. can see this is the exact same config we had from the last lab. It's just I'm able to do that whole thing just using one device. So if you're watching this video and you can't spring for a extra $600 server like I did, or you don't want it blaring in the background of your apartment, or you can't afford the extra electricity for it. So answer me this, pull up your my PC. So my PC, yeah, this PC, pull that up, do a right click and go to properties. And then if you see that you have 8 gigs, you've got plenty of RAM to run a single VMX image, the very same images I'm running here on my machine remote. You can run on, if your laptop has 8, you can run that very same image, but instead of having multiple images and building up a topology that way, you would just have multiple logical systems. So don't let lack of resources prevent you from achieving your goals. Yes, they're going to slow you down. Yes, they're going to make it difficult, but there are always ways to overcome limitations to some level. Really, all you need to do is be better than the other people competing for there. Now look at how familiar this looks. This is the configuration that we initially had just on router A, but now we're going to have this on router 1 in a logical system, and then the other configurations we will put on separate devices, each device requiring 4 gigs of RAM. We're going to have on one device requiring 4 gigs of RAM. So if you're watching this and you want to learn Junipers, pull up your stats. If you got 8 gigs, you're golden. Even if you got 4, you probably can give it a shot. You can just spin up one VMX, and then you can use logical systems to emulate multiple routers without having to dedicate resources to them. That's another cool thing. I'm not sure how you would do that in Cisco, or if that's possible. Well, we'll see if it works here, but that's why I wanted to do this exercise, just to show that that is a possibility. It just so happens that I show that it's not a possibility. That's going to be disappointing, but I really don't expect that. I would be very surprised if that was the case. All right, so now it's time for logical system C. So yeah, you can see it's as if I figure two completely different routers. Really, really handy. All right, so hopefully this will commit. Oh, so interface range 0.1, not defined. Interface ranges expansion failed. So it looks like I've got a typo in there. Control pipe display set pipe match LO.1. Aha, yep, I've got a typo right there. So I'll fix that. And without even checking, I can safely assume 0.1. So we'll see if that commits. Oh, I think we've got another issue. Oh, I meant to, that's interesting. It does say to type that. Do I have which logical system is this? This is logical system A. So this is the command. And yeah, it tells me to do L0.1. That's interesting. This is another really good thing about this display strip log. So once you're in the hierarchy for your logical system, you use this relative. It's as if you're configuring that one device all the time. So let's try to resolve. Yeah, what the heck is happening here? Why is it not? Oh, I understand what happened. So I included the passive keyword after, so it deleted the most specific thing that we passive, but I need to delete the whole interface, not just the fact that it is. Perfect. So yeah, this is really looking really inspiring, good now. So you got 8 gigs of RAM on your laptop that you're watching this video with. That's more than enough to spin up one VMX. If you spin up one, you can create logical systems and spin up multiple and practice whole topologies and pass an exam. I would even say that's probably a better bet than Juniper Olive, because with Juniper Olive you can only you can't do VLAN bridging, which is a big part of the JNCIE-SP. So the VMXs are better for that, and the device is safe forever to boot up and shut down. So it's important to like leave it up. And how that is done is so leave this project running in the background and closing GNS3. That's a setting that can be really important. All right, so let's do the verification plans. Oh, so we've got an issue here where it's not able to connect. So let's go ahead and just do the regular troubleshooting. So show routes. Oops, so there's no route for that. Try to show on this. No route there either. So let's do edit logical systems. Oh, it's got to be in configure mode. Private edit logical systems. A show by displays relative. So let's see what the issue is. So we've got let's do run show int terse logical, and then is there an option to specify the logical system? There is not. Maybe system or something. No. Show logical system maybe. Show system. That like logical system. Show system. Okay, yeah, so I'm not sure how I can do a show command to determine specific information specific to a particular logical system. So for this one, clearly that's being done. But let's see if I can ping, or let's look at the configuration for logical system B. So I've got .2 on logical system B, and I've got its peer unit here. So hopefully I'll be able to ping from here .1 over to .2. Can I even ping myself on that one? I can't. So there's obviously, what if I do logical system? Yeah. Oh, I can't assign requested address. That's interesting. Why was it able to configure it on the logical unit if it can't assign it during the ping? Maybe because this port is not a valid port. Yeah, I don't see that port anywhere. That's showing terse. So, yeah, I guess I'm not surprised that it can't assign it. It's not present. Let me do a quick Google search for Juniper logical systems. Here we go. Logical, let's go back here. Introduction to logical systems. Well, let's read a lot of this. So logical systems enable you to partition a single router into multiple logical devices that perform independent routing tasks. It offers an effective way to maximize the use of a single routing or switching platform. For more information, see the following topics. Comparing Junos OS device virtualization technologies. Junos OS supports multiple device virtualization technologies. The technologies have similar names, which can lead to confusion. The Junos OS device virtualization technologies are logical systems, offer routing and management separation. Management separation means multiple user access. Each logical system has its own routing tables. Logical routers is the old name for logical systems. Beginning with Junos release 9.3, the logical router feature has been renamed logical system. All configuration statements, operational commands, show command output, error messages, log messages, and SMB mid objects that contain the string logical router have been changed to logical system. Virtual routers. So this is familiar from the layer 3 VRF section. Virtual routers offer separate routing tables and scalable routing separation. Virtual routers are similar to VPN routing and forwarding instance types, except that they are used for non-VPN related applications. Virtual routers basically consist of routing tables, the interfaces assigned to the routing tables, routing protocol configurations, and routing option configurations. There are no virtual routing and forwarding, VRF, and import, VRF export, VRF target, or route distinguisher requirements for the virtual router instance type, but it's not used for VPN purposes. You can use virtual routing instance types on a single device to segment your network. For example, as opposed to configuring multiple devices to achieve the same result, virtual router instances can isolate traffic by separating the device into multiple independent virtual routers, each with its own routing table. So I can't really think of how that would be useful. I mean, I guess maybe I can think of if you've got two customers and you don't want to have them to go through the same box for whatever reason, you can put them in their own virtual instance. Yeah, I guess I don't really know when that would be useful. And this fortunately isn't, I think, a good enough clue. VRF Lite offers routing separation. The functionality of VRF Lite is similar to virtual routers, but VRF Lite is for smaller environments. Virtual switches offer scalable switching separation. Junos node slicing. Junos node slicing allows a single MX series router to be partitioned to appear as multiple independent routers. Each partition has its own Junos OS control plane, which runs as a virtual machine VM and a dedicated set of line cards. Each partition is called a guest network function, GNF. You can configure logical systems inside a guest network function. More information on node slicing, the understanding of Junos node slicing. Okay, so here we go. So here's some benefits of each. So here's all the benefits: logical platform partitioning, multi-installation on the routing plane, multiple user access, management separation, scalable routing separation. So logical systems have all of that, but other types of virtualization do not. So I don't know why you would ever choose a virtual router then. You could just use a logical system. Maybe it sounds resource intensive or something. Well, maybe I'll find out here. For many years, engineers have combined power supplies, routing hardware and software, forwarding hardware and software, and physical interfaces into a networking device known as a router. Networking vendors have created large routers and small routers, but all routers have been placed into service as individual devices. As a result, the router has been considered a single physical device for most of its history. The concept of logical systems breaks with this tradition. With the Junos operating system, Junos OS, you can partition a single router into multiple logical devices that perform independent routing tasks. Because logical systems perform a subset of the tasks once handled by the main router, logical systems offer an effective way to maximize the use of a single routing or switching platform. Traditionally, service provider network design requires multiple layers of switches and routers. These devices transport packet traffic between customers. As seen on the left side of Figure 1, these devices are connected to edge devices, which are in turn connected to core devices. So, network topology without logical systems. 8 separate physical devices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 5. Core devices, distribution devices, edge devices. So, these devices, yeah. So, access devices, edge devices, core devices is what we're saying. Access, edge, core. Access device. Oh. Okay, which is interesting because I would think that the edge devices are here and the access are here. That's not what the definition says. It says, as seen on the left side of Figure 1, access devices are connected to edge devices, which are connected to core devices. But, all right. So, however, this complexity can lead to challenges in maintenance, configuration, and operation. To reduce such complexity, Juniper Network supports logical systems. Logical systems perform a subset of the actions of the main router and have their own unique routing tables, interfaces, policies, and routing instances. As shown on the right side of Figure 1, a set of logical systems within a single router can handle the functions previously performed by several small routers. You can have one router, but I don't get it though, because I thought the whole reason you have this sort of architecture is to eliminate the single point of failure of there being one router. put this whole redundant architecture on one router, you're getting rid of that redundancy. I really don't understand. I don't really say more about that. Logical systems applications. Logical systems are discrete contents that virtually divide a supported device into multiple devices, isolating one from another and protecting them from faulty conditions outside their own contexts. The logical system's functionality enables you to partition the device and assign private logical systems to groups or organizations. Logical systems are defined largely by the resources allocated to them, features enabled for the logical context, their running configurations, and their logical interface assignments. And this is what I need to learn about. This is why I'm reading this documentation. Logical systems segment a physical routing device to be configured and operated as multiple independent routers within platform. This isolates routing protocols and interfaces among up to 16 logical systems, including the master logical system. User permissions and access are defined separately for each logical system, enabling different groups to manage the same physical device. Logical systems enable the use of large routing devices in small routing device roles and provide flexible segmentation of routing by service type. Multiple service capabilities bring improved asset optimization by consolidating services into one device. For example, logical systems enable the following services on a single routing device platform: Internet BGP peering, core transit, edge aggregation and dedicated access, and PLS, provider edge, PE, and provider P, VPN, label switch, routers, LSRs. Figure 2 shows how logical systems can be used for horizontal consolidation, vertical consolidation, and managed services. Horizontal consolidation occurs when you combine routing device functions of the same layer into a single routing device. Vertical consolidation occurs when you collapse routing device functions of different layers into a single routing device. With managed services, each logical system is a customer routing device. Junos OS features that are supported on logical systems. The following protocols and functions are supported on logical systems. Okay. But that's not going to be relevant to me. Really, all I need to know is why those interfaces aren't showing up in show interfaces first. So hopefully this will show me that. Oops, and it looks like that just took me to the same that I was on. So, yeah, I was already there. Here we go. In a VPLS multi-homing scenario in which a logical tunnel interface, LT- is used for connecting the dual home, well, I definitely need to know more about this logical tunnel interface. I think this might be interesting as well. Here we go. So, oh, these are the only times logical tunnel interfaces that I mentioned. Yeah, so not a lot of information about logical tunnel interfaces, unfortunately. That's what I need to know about. So Okay, so it's just it's not a new page. So on a physical interface, the configuration of one or more units that include all addressing, protocol information, and other logical interface properties that enable the physical interface to function, also known as the subinterface. Oh, I thought that was called a logical unit, not a logical interface. Univerland. That's, and then it's sorted out by the virtual interface. But yeah, I guess I'm kind of left wanting for more. This is a logical tone interface. So, yeah, let's see if oops, it looks like I got taken away from what I was. Let's go to the verification section. See if they're wanting me to ping. Let's just see if they're using LD dash. Oh, so I think the peering logical unit interfaces must have the same physical LT interface name. For example, the logical unit not. Okay, so I think I just need to name it based on a valid physical interface. So I can't use 010. I've got to use 000. So I'm going to try that. So let's see what happens if I delete everything here. But then I repaste it all in, but with a different name. And then we'll see if I can ping myself. Right now I can't even ping myself. Because I do have an interface GE000, but I did not have an interface GE010. Oh, still can't assign the requested address. Yep, still can't assign. What about I do a Google search? So Juniper logical systems, and then this error message. Aha, here we go. So this could be it down here. So one of these things. Do you have an interface physically patched? Did I specify the interface? I didn't specify the interface. Here we go, interface. LT. Nope. So, yeah, I'm not sure what's going on. I mean, this I think is not going to be on the test that I did before. So I kind of want to skip it. Logical systems is not in the curriculum, so it's on the test. It's on the test on the curriculum. That would not be the case. I hope that would have less on the test than I have in the curriculum instead of anytime it has that part of the curriculum. It's not the curriculum, so that if that's straight from it, that's really not fair at all for the test takers. All right. So do I ping the, maybe I just can't do the LT, maybe I have to do 0, 0, 0. Maybe I've got to have an actual physical interface. Although I remember trying this before in an earlier video, and there's a reason I moved on from these logical interfaces, and I don't have the will, so there would be no way for me to figure out how to work. I just want to move on and get to the material that actually is going to matter for the logical systems. I hope they'll show up because it's not a great. Never know. I really don't think that would be fair. I'd probably even submit a complaint because it should be in some part of the oh, you can't even do that sort of configuration on a physical interface. You can only do it on a logical tunnel. Yeah, so this is what it's got to be. I don't understand why I can't do anything. Why? But nope, can't assign requested address. To the logical system, hey, can't assign requested address. So I guess I don't know why. Because, well, I mean, that's something. I should have a direct route in my route table for that logical system. Oh, yeah, so you can see something very strange is going on. I don't have a directly connected route in my logical system, so of course I can't ping that. I don't know why it's not showing up. So the Juniper LT dash interface, no direct routes. So here we go. So is there anything in here maybe? Nope. Oh, do I have to set up a static route? I have to set up a static route for. No, you can see it's got local and direct routes via this, so it should just have direct routes. It's just I can't get these LT interfaces to work online. One thing that might work is I know there's a command like no logical tunnel. I forget what it is exactly. Yeah, so it could be that it's not supported too. It's just there, but it doesn't work. This is where SRX is on MX. That's not going to work. Configure private, edit system, and I thought that was like a VRF command. So, yeah, I don't think it's going to work. I don't have a way of configuring that logical time interface. Yeah, I configure it, but I don't have it showing up anywhere. I can't put it on the physical interface. I actually remember, what about the extension service? Trace options, request response notification. Is that a tunnel? No. Edit system tunnel. Or edit system, or edit chassis? No. You just edit tunnel. Edits. Interfaces. Logical systems. Logical systems. Services. Switch options. Interface for configuring bridge options. Yeah, I don't know. I think it's I think I'm going to move on. I originally planned to do that. I just thought I could get it to work, but until I figure out how to have one of these interfaces populate the routing table with a direct route, I'm really not going to get this to work. And it looks like there's no information there about how that's happening. It's just kind of assume that it will happen. Maybe I need a particular kind of FPC. So let's do show chassis FPC. So I've got one that's online. Okay, here we go. Configure FPC slot 0 to support logical tunnel interfaces. Configure private. Set chassis FPC 0 PSC1 tunnel services bandwidth 1G. Minute quit. So it was right there in front of my face the whole time. I just had to read it. Now let's do a show in terse. And hopefully I'll have some brand new interfaces popping up. Oh, here's one. I've got a logical tunnel interface now. But let's revert the configuration back to how it shows up in the documentation. All right, and now we'll see if we can now ping 10 times 10 1. Well, let's check the routing table first of the logical system. So, yeah, bad news. We're not going to be able to ping it because there's no address populating in the logical system. One thing I can do is a show in terse. I match LT dash. And it looks like I've only got one logical tunnel port to work with. So I'm definitely going to need more than just that one. Well, maybe I won't. Maybe I just need that one. So let's just try working with that one. And maybe just my device is a little bit different than the one they're using. But all I need is one logical tunnel because I've got units and pure units. I think that's how it works. The interfaces, let's see, heads, logical systems A, show type is set relative, LT 010. Okay, so now we're going to go with 10. Perfect. All right. So now show route logical system A. Still not. Yep, still can't do it. So I've got a route in there. It's up. But it doesn't have a an IP on it for some reason. You can see I've got it previewed there, but if I do a show route logical system A, I don't have a directly connected route for it, even though I now do have the interface if I do a show into terse. So, and I already did this part, I figured the logical tunnel. So I verified that they're up, but you can see, sure enough, it doesn't have an IP on it. So yeah, that's something that definitely needs to get resolved somehow. So I've got this JNCIE-SP 0 command. So, oh, I think it needs to be, for me, it needs to be PIC 0, not PIC 1. Yeah, I think that's the problem. I just blindly followed what was in the doc without thinking about what my particular situation requires. Nope, still can't do it. Yep, still nothing. So show enters. Okay, so all that did is just change the naming match LT dash. And I, in fact, still even have the old naming on there. But let me try to, that's interesting that I have this one. Configuration logic systems A. obviously this configuration here is not valid, so we change that. Now delete LT 0110. I'm going to edit. I'll try the 00 first because I actually do have that PIC. I don't have a PIC in one. I only have one 0. Yeah, still nothing. So that's pretty disappointing. Yeah, still nothing was assigned to that logical tunnel interface. I can try it on the 010. So still nothing on there, so that's a really bad sign. Yeah, sure enough, same thing. And it doesn't have a directly connected route. So yeah, I think it's pretty plain to see that there's some kind of issue where I can't run it. I mean, I need to verify that the router has a DPC, MPC, or MIC installed. It looks like I have I can't tell which one I have. Yeah, it won't tell me what it is. But here you can see I have something at PC slot 0 and PIC slot 0. But in PIC slot 1, I have nothing. So I think I'm definitely gonna pass up on this, and of course I'm kind of wired to figure it out. But I think this is going to be a satisfactory answer for me, and that answer is going to be that my router does not have the DPC, MPC, or MIC installed, and they're not in online because you can see type virtual. So it's not a DPC, MPC, or MIC. It's a virtual emulating PIC. So I really don't think, and that makes sense too, because like, how can you virtualize virtualization? Like, there's probably just not the capacity to do that. So yeah, so you've got to have special chipsets. You've got to have line cards and modules. So if I'm in virtual, I'm already virtualizing MX, so how can I virtualize MX? MX is inside my virtualization. I don't have the hardware to do that. I don't have the chipsets to do that. So that's going to be a satisfactory explanation for me. And I'll close out the video on that. This was a further exploration into logical systems, and this was a definitive final answer about why I cannot use logical systems, and unfortunately why you cannot too. So you'll have to kind of think about what I said earlier about it being a really effective tool, because if you're virtualizing a MX, EMX, you're not going to have an EPC, MPC, or MIC installed and in an online state, because you're going to have a virtual version of that. So you won't be able to meet the minimum requirements for running logical interfaces. One thing I want to do, and this is why that LT was showing up, separately with that. But one thing I want to do final is do GNS3, Juniper logical systems, and see, let's see if this has this issue in GNS3. Oops, it looks like it's not loading. Too bad. That would look like the right thing to search for. It's really promising, but it's not going to load. It's not promising. I'd like it to be. Let's see what the speed test is. It is 6:30. People are partying on Netflix. My internet is slower now. So, yeah, I want to. Oh yeah, my internet is completely crawling now. I don't know if people are watching Netflix. I can't even read the text. Yeah, my internet's completely down. Well, I mean, all it needs to do is just load up and show me the answer. But some issue where I can't get internet. Unfortunately, well, 0.03. I've got great upload. Yeah, I think people are just watching so much Netflix right now, Sunday at 8:40, all the social distancing and stuff. Oh, now I'm doing better. Aha, this one actually loaded. All right, I have detailed explanation on configure and run EMX. Okay, let's look for systems. Okay, yeah, I can't get it to work on Ubuntu using GNS3. It works fine if I run on this one. Just see packets. It's not working. I mean, I can set up and commit logical systems. I just can't. It's just the logical tunnel interface doesn't create a directly connected route. Routing to people. Yeah, so I don't know why that is the case. And need to move on. Oh yeah, I have this problem as well. Okay. Yeah, I'm having a heck of a time with logical systems. I mean, I'm happy to say that it's just I don't have any physical hardware in my PIC slot. I've only got virtual hardware. So it's not going to work unless I have that physical hardware in my PIC slot. I've got 3 and I'm going really fast now. Here we go. Oh, well, this person just seems to have. Yeah, I don't know. I think I'm going to. Well, I think that's the end of the video. It's very clear that logical systems aren't going to work because a logical tunnel interface doesn't create a route in the routing table for the logical system. So I'm not sure why this is the case, but I think a good answer is just that I don't have the required hardware in the PIC slot. In fact, I don't have hardware at all. I have virtual hardware. So I think there's my answer right there. Why can't I virtualize something? Because I'm already virtualizing and we didn't build virtualization. All right, thanks for watching. This is the end of IBGP and EBGP. You see, I already marked it done, but I want to kind of get this its 2 previous before I'm done. So the next video, I will be starting this new topic here. IPv4 and IPv6 peering communities. Stay tuned.